Alright, welcome to another exciting installment of the AP Calculus test. What I'm going to be going over right now is going to be the Calculus AB 2016 free response questions 5 and 6. These are non-calculator questions, so away we go. Okay, so again, what I'm doing is I'm going to be doing my work on a blank sheet of paper because this year you're going to be getting this from your computer or from your phone, and so what you're going to be doing is doing work on a separate sheet of paper. So I kind of want to show a good way of doing that. So here we go. This is question 5. Here it is. We begin with, okay, so from 0 to 24 hours, the temperature inside a refrigerator in a kitchen is given by a function W. So W is the temperature. That satisfies the differential equation. So this is a rate of the temperature. So this is the rate at what it's changing. Notice how there's T and W also in that equation. So I'm assuming that at some point we're going to have to get an equation for W, and so we'll have to separate variables. Anyways, W of T is measured in degrees Celsius and T is measured in hours. So this would be like degrees Celsius per hour. At time T is equal to 0, the temperature of the refrigerator is 3 degrees. Alright, write an equation of a line tangent to the graph of y is equal to WT at the point T is equal to 0. Second part. Use the equation to approximate the temperature inside the refrigerator at T is equal to 0.4 hours. Okay, so the first thing is what is the equation of that tangent line, and then we're going to use that tangent line as a linear approximation. Alright, so here we go. So this is 2016 free response 5 and 6. This one happens to be problem number 5. This is question A. Alright, so the slope of my tangent line is dw dt, which is 3 cosine t over 2w. And so we want to know this is when t is equal to 0. But what we also know is when t is equal to 0, w is equal to 3 degrees. So they just so happen to use the point that we already know. So that implies that our slope is going to be 3 cosine of 0 over 2w. Cosine of 0, I'll just kind of make my unit circle over here. This is at the point 1, 0. The cosine happens to be 1. So this is going to be 3 over 6, which is 1/2. Okay, so that's the slope. So in essence, what we have is we have a slope of 1/2, and we want it at the point 0, 3, where this is t and this is w. Okay, so what is WT? So y, which is w, minus y1 is equal to m x, which is t, minus x1. So y minus y1 is equal to m x minus x1. Okay, so we got 1/2 t, 0 plus 3. That is our equation of that tangent line. So that's the first part of that question. Second part of the question says, well, use that as an approximation when time is equal to 0.4 hours. So that will be 1/2 0.4 plus 3. This is 0.2. This is 3.2, and this is a temperature, so that's degrees Celsius. So there's your linear approximation, and there is the approximation when time is 0.4 hours. Easy peasy. Second question. Find y is equal to wt, the particular solution to the differential equation with the initial condition of w is 0. So they want to know what is the actual true blue equation of w. So that's kind of what I was assuming where this problem is leading. And so part B, we need to find the actual equation. So we begin with what we do know, and that is the derivative. dw dt is equal to 3 cosine t 2w. Alright, so what I'm going to do is I'm going to multiply this side with dt, and I'm going to multiply this side. I'm going to leave the 2 over here. I'm just going to multiply w. So this leaves 3 over 2 cosine t, okay, because I'm multiplied by dt. Then I'm multiplying this w over here, so that's w dw. So all the t's are over here, all the w's are over here. We're good to go. So with that separation, what we can do is we can integrate both sides. Okay, add 1, so that's w squared 1/2. Cosine goes to regular sign, not negative. So this is 3 over 2 sine. And then the all-important, don't forget it, plus c. Okay, now our mission is to figure out that plus c. So this is where that initial condition comes into play. So again, that initial condition is when t is equal to 0, w is equal to 3. So we're using this known point. So that'll be 1/2 w, 3 over 2 sine t plus c. So again, unit circle time at 0. Cosine sine is equal to 0. So this is 0. So 0 times that is 0. So that just leaves c. This is 9. So this is 9 over 2 is equal to c. Rewrite it into that equation right there. That's where the first appearance of c shows up. And so we plug it back in. Plus c. Okay, now our mission is to solve this for w, thus we have w of t equal to an equation. So we multiply by 2, so this would multiply that and that, so the 2's go away. Square root, and of course that becomes a plus minus. Now, question is it the plus or is it the minus? So again, what we do is we take note of that point that we used. So when t is 0, and again, so that would be 0, w is equal to 3. So if this is 0, 0 plus 9 is 9, square root of 9 is 3, so I need plus or minus 3 is equal to 3. Well, the only way that that would be possible is if it were the plus, because if it was a minus, then it'd be a negative 3. But that doesn't work out. So that negative goes away, and so that is your true blue W of t. Now, for some reason, if the temperature were negative 3, then it'd be the negative version. So that's that. And next we have question C of this problem. The temperature remains constant at take 2. The temperature in the kitchen remains constant at 20 degrees for the 24 hours. The cost of operating the refrigerator accumulates at a rate of $0.001 per hour for each degree that the temperature in the kitchen exceeds the temperature inside the refrigerator. Write but do not evaluate the expression involving an integral that can be used to find the cost of operating the refrigerator for that 24 hours. Okay, so that sounds really complicated, but it's not complicated at all. Okay, so think about what is the temperature over, excuse me, what is the difference between 20 degrees under, excuse me, the number of degrees under 20 degrees, that's what I'm trying to say. And that'd be 20 minus our temperature. So just in case that our previous idea of what the temperature is, just in case that's wrong, what I'm going to refer to it as WT. Okay, so that's, apologize for the helicopter going overhead. So that will give you the difference that between 20 degrees and the temperature in our refrigerator. Okay, so what we need to do is we need to add all of these up. We need to sum these up for 24 hours. That's why an integral looks kind of like the letter S. It is a sum. So I'm going from 0 to 24 hours. Okay, so this will give you an instantaneous snapshot of the temperature compared to 20 degrees. Now, so this is the temperature. That is the temperature, and then now we need to pay for each degree. So the payment is 001. So I'm going to multiply that to each one of those instantaneous things and add each one of those little teeny tiny cents up at whatever they happen to be, and that should be the cost of operation right there. So that is the difference of temperature, and then what we do is we add each one of those individual things up, paying $0.001 dollars every single time. Okay, so it seems complicated, but if you just kind of know what the process is. Okay, moving on. Problem number 6. Let's see if I can dig it up here. 6. Ooh, we got 2 equations. Oh, okay. I bet there's questions about continuity and differentiability and minimums and maximums, and I bet that's what's going to happen here. All right. Number 6. Let f be the function defined above. Okay. Is f continuous at that one, that where one of the equations turns into the other? Is it continuous there? Why or why not? Alright, so again, this is number 6A, and this is the continuity test. So we want to know, is it continuous at 1? So again, continuity test. It goes limit left, limit right. If those things are equal, then the limit exists. Does the limit equal the point? Okay, does the limit equal the point? So limit left, limit right makes a limit. And then does the limit equal the point? If the limit is equal to the point, then it's continuous. So here we go. So let's go limit left. Limit as x goes to 1 negative of f of x. So 1 negative is where it would be less than 1, so that would imply that this would be 10 minus 2x minus x squared. So that's 10 minus 2 minus 1, 7. So limit left is equal to 7. Limit right. Limit as x goes to 1 from the positive side. Okay, so limit right would be where x is greater than 1. So we're using this bottom equation. So that would be 3 plus 4e to the x minus 1. So e to the 0 is 1, so that's 3 plus 4 times 1. E to the 0 is 1, and then so this would be 3 plus 4 equal to 7. So limit left is equal to the right, so that implies that the limit as x goes to 1 is equal to 7. Alright, so now we check out the point, this is supposed to be 1. The point itself, and that would just share this one because that has the, the top one because that has the or equal to. So again, that would be the 10 minus 2 minus x squared. So that's where it's equal, and again, that obviously is equal to 7. I did all the work up there. So what do I notice now? I see that the limit as x goes to 1 is equal to the point at 1, and because those things are equal, thus f of x is continuous at x is equal to 1. So yes, it is continuous. Why? Because the limit is equal to the point. That's why. B. Find the absolute value, the absolute minimum value and the absolute maximum value of f on the closed interval from negative 2 to 2. Show the analysis that leads to your conclusion. Alright, so absolute mins and maxes and things like that will occur at critical points. So that's where the derivative is equal to 0. So I'll be looking for where's the derivative equal to 0. Also, it could potentially be the endpoints. That's the extreme value theorem. So it's any critical points in between and also the endpoints. And then what I'm going to do is I'm going to do the candidates test on this. Okay, so let's begin with the derivative of this. So f prime of x. So the derivative of the top one would be negative 2 minus 2x. And so that's x is less than 1. It does not get the or equal to. Okay? So it does not get the or equal to. The bottom 3 goes away. E stays the same. Chain rule is still a 1, so it will just drop the 3 portion. So that'll be 4 e to the x minus 1. Okay, and so that is x is less than 1. Okay, so where are derivatives equal to 0? So what I'm going to do is I'm going to test this top one. So negative 2 minus 2x. Is this derivative equal to 0? So add 2x, divide by 2, x is equal to negative 1. Yes, there is a critical number, and that does apply to that one still. So there is going to be a critical number at negative 1. Let's test the other one. So this is like when is e equal to 0? E is never equal to 0. You would have to move it up and down. So e, so never. That x does not exist. So that is, so I'm only getting one critical point. So, and also it's probably in your best interest to take a look at the transition between this equation to that equation. So I'm also going to include 1. So, critical numbers. X is equal to, like, I guess it's not a critical number, but it's an important number, negative 2, because what we're looking at is the realm from negative 2 to 2. That's where we're, so I'm going to use that point. Negative 1, 1, and 2. So I'm testing all of these points. And so where I test them is back into the actual true blue equation. Not the derivative, but the true blue equation. So what I'm going to do, these are all the important pieces, and now I'm just going to see which one is the biggest and which one is the smallest, and that would be the absolute max and min. Alright, so let's go with negative 2. That would be the one where it's less than 1. So that would imply, this would imply that 10 minus 2x minus x squared, 10 plus 4 minus 4, alright, negative 1, again that's still less than 1, so that would be 10 minus 2x minus x squared, so that'd be 10 plus 2 minus 1, So that would be 11. 1, again, that's or equal to, so this would be 10 minus 2x minus x squared. And so that is going to be 10 minus 2 minus 1. So that's going to be 7. And then last but not least is 2. That goes into here. So this is 3 plus 4e to the 2 minus 1. So that would be 3 plus 4 to the e to the 1. Now what the heck is that equal to? Well, if you know a little bit, what I kind of think of e, if I need to put a number to it, you are allowed to use a calculator, so you can type that pretty quick. That's e to the first power. But what I think of that is it's 2 point something 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 2 point something something something. So if that is 2 point something 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 something, this will be on the positive side of 8 to 8.5 or something. I'll approximate this as like 8.5. If that's 8.5, this is 11.5, so this is something, 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 bigger than 11. Okay, now that's kind of important because what is my absolute max? My absolute max would be this number right here because it's the biggest. My absolute minimum would be this number right here because it's the smallest. So it's kind of important that to recognize that 3 plus 4 to the e is technically bigger than 11. Alright, so to answer the question, where's my absolute, excuse me, what is my absolute max? My absolute max is 3 plus 4e. That is my absolute max. And then, how do I know this? Well, I did the candidates test. I think this is pretty much explanation enough. It's the candidates test at it's the candidates test at x is equal to 2. Okay, candidates test. And I'm not sure if I spelled that correctly. Whatever. Candidates test. Absolute min is the smallest of all the important stuff, and that would be 7. And again, I use the candidates test. Booyah! Question C. Oh man, I was hoping for a hard problem. Okay, find the value of the integral from 0 to 2 of f of x. Alright, so what they're just kind of alluding to is what is the integral of this. So notice that there's going to be a break at 1. So hopefully you can understand why I'm going to be taking this from 0 to 1 and 1 to 2. Okay, like for obvious reasons. So whatever this picture looks like, so hypothetically, what this picture would look like is like it does something to the number 1, and then it does something else from the number 1. Alright, so if I need to integrate from 0 to 2, notice how it'd be logical to take it from 0 to 1. It'd be logical to take it from 0 to 1 and then 1 to 2. That's just logical. Okay, so 0 to 1 would be this top equation. So this is going to be the integral from 0 to 1 of 10 minus 2x minus x squared dx plus 1 to 2 of, it's going to be the one bigger than x, or bigger than 1, so that's going to be the 3 plus 4e to the x minus 1 dx. Okay, integration time. This is 10x minus x squared. Okay, that eliminates, and then minus 1/3 x to the third on the world of 0 to 1 plus 3x. Again, the derivative is equal to that, so I don't have to do any fancy footwork. Again, just quickly take the derivative of this, and the derivative of this is this, and so okay, we're okay. 1 to 2. Alright, plugging in 1 minus the 0, so this is going to be 10 minus 1 minus 1/3 minus 0, 0, 0. Plug in the 2, so this is 6 plus 4e, okay, because 2 minus 1 is 1, minus 3, and then 1, it goes to 0, so this will just be 4. Alright, so we have 9 minus 1/3, so 9 minus 1/3, denominator of 3 would put this at 27/3, so this is 26/3 minus 0 plus, okay, 4e is just going to be along for the ride. This is 6 minus 7, so this is negative 1 plus 4e. 3/3, so this is 23/3 plus 4e. Yeah! Alright, so that is problem 5 and 6 of the 2016 Calculus AB test.